Okay, hi guys. So we'll be continuing on seeing the law of chemical combinations. So let's get started. So suppose we have H2O at solid state and it is getting converted into H2O at liquid state. Both are in at equilibrium. So both in equilibrium. Okay. So what we can say is, so suppose the external things we apply is 1 atm pressure and 0 degree Celsius temperature. Okay, so this is a melting point for H2OS and freezing point for H2OL. Okay, so a chemical compound always contains same elements combined together in the same composition. Okay, so when we talk about this being in equilibrium, whether it's a solid state or in liquid state, both are comprised of the same compounds in the same proportions. So as long as the compound or the molecule structure is same, the composition from which the actual molecule or compound is made will remain the same, no matter how or in what state it exists. Okay, whether it's in a solid state or in a liquid state, the law of definite proportion says that the composition of or the ratio of H is to O will always remain the same, no matter what in what state does it exists. Okay, so one more thing, that H2OL will convert into H2OG. Again, the external conditions are 1 atm pressure and temperature would be 100 degrees Celsius. Both would be in equilibrium at this particular point, both in equilibrium. Okay, so we can extend the definition of law of definite proportion in this case as well. Okay, so one more thing, no matter what is the source of preparation of this water molecule, still the law of definite proportion will hold on them as the final compound formed is same. So let's say I have H2G and O2G and they combine to form H2OL. Okay, this is the first source of preparation of H2OL, and second source can be if we use peroxide, aqueous peroxide. This will dissociate itself into H2OL plus half mole of H2 gas would be released. Okay, so no matter how you actually form the same molecule, the law of definite proportion will hold. Okay, you can say that the ratio of H is to O will always be 1:8. Okay, no matter in what state of molecule or what is the source of molecule. Okay, next let's see law of multiple proportions. Okay, so this was given by Dalton. So let's say we have two elements. Okay, those are carbon and oxygen. Now carbon plus half oxygen combines to form carbon monoxide, and carbon plus full oxygen combines to form carbon dioxide. Okay, so in this case 12 gram carbon present with 16 gram of oxygen, and in this case 12 gram carbon present with 32 grams of oxygen. Okay, so mass ratio of oxygen in both the compounds would be 16:32, or in other words it is 1:2. Okay, so this will always exist as a simple whole number ratio. Okay, this is the law of multiple proportion, always exists as a simple whole number ratio. Okay, so let's understand this with second example. We have two elements. Again, let's say we have sulfur and oxygen. So sulfur and oxygen combines to form SO2, and sulfur plus 3/2 oxygen combines to form SO3 gas. Okay, so in SO2 gas you can say 32 gram of sulfur combines with or present with 32 gram of oxygen. In SO3 you can say that 32 gram of sulfur present with 48 gram of oxygen. Therefore, mass ratio of oxygen in both the compounds would be of the order of 32:48. We can say it is 2:3. Okay, which is a simple whole number ratio. Okay, so let's see another example. Will be I will also be giving the statement of law of multiple proportion at the end of this lecture. Okay, so let's say two or more elements, suppose nitrogen and oxygen, they combine to form some oxides like NO2, NO, N2O5, N2O, or we can also have N2O4. Okay, so now in two elements NO2 and N2O5, we wish to prove the law of definite proportion, multiple proportion. Okay, so in NO2 it is simply 28 gram of nitrogen combines with 64 gram of oxygen. We can say that why? Because 14 gram of nitrogen combines with 32 grams of oxygen. So in other words, we can also derive 28 grams of oxygen present with 64 grams of 28 grams of nitrogen present with 64 grams of oxygen. Similarly, we can say here that 28 grams of nitrogen present with 80 grams of oxygen. Okay, so therefore mass ratio of oxygen in both the compounds would be of the order of 64:80, which is 16:20, which is 4:5. Again, a simple whole number ratio. Okay, so the statement goes as, when two elements combines with each other to form two or more than two compounds, then the mass of one element which combines with the fixed mass of the other elements bears a simple whole number ratio to one another. Okay, that's the statement, that when two elements combine with each other to form two or more than two compounds, the masses of one element, or rather the mass of one element, in previous case and a nitrogen which combines with, or rather you can put it, the masses of one element which combines with the fixed mass of another element, which was N2 in our case. Okay, so the masses of one element which combines with, so now I'm talking about oxygen here because I've changed mass to masses. So the masses of oxygen elements, which is the only one element we are talking about, the masses of one element which combines with fixed mass of another element, the fixed mass we are talking about nitrogen atom. Okay, fixed mass of another element, Beer's simple whole number ratio. Beer's simple whole number ratio. So that's what it was. This was the statement for law of multiple proportion. So with this we come to an end of this lecture. In the next lecture we'll be seeing law of reciprocal proportion. Okay, so till then, good luck and goodbye.